So let's use calculus to do some graph sketching. We have this nice function here. We know that we don't really need to use calculus. You can just say y is equals to negative x minus 4. This times this becomes this. This times this becomes this over here. So this happens to be the same thing as y equals negative x minus 0, x minus 4. So just knowing a bit of basic, a little bit about parabolas, you know that the roots are going to be 0 and 4. It's not going to be a happy face. The negative sign means it's going to be a sad face. So the halfway point between these roots, these x-intercepts, is going to be 2. So we know that at x equals 2 we have a local maximum. We have a maximum value here. So we don't really need to use calculus, but let's just do so anyways. Let's focus on the derivative. F prime of x, using power rule, 2 times negative 1 is negative 2, x to the 1, we decrease that exponent by 1. And the derivative of 4x is going to be positive 4. And we're interested in calculus in setting the derivative equals 0. Because the derivative is 0, the slope of 0 could be a maximum or a minimum, or it could be neither. Let's use some basic algebra here. I'm going to throw the 2x over. 2x equals 4, so therefore x equals 2. And yes, we use calculus, derivative equals 0, to figure out the x value of the actual maximum. And we're going to say when x equals 2, what's the y value? The y value is not here, it's actually here. Be careful, concentrate. The y value, f of x, is the original function. F of 2 is equals to negative something squared plus 4 times something. And that something happens to be 2. So don't confuse f of x and f prime of x. We're interested in actually finding the y value of the actual function. So negative 2 squared is negative 4 plus 8. So the y value is 4. So the coordinate of the maximum, the coordinates of the maximum is going to be 2, 4. It's going to be the max. And let's show you this graph on Desmos, our good friend. So as you can see, our maximum for this graph here, the graph here happens to be f of x equals negative x squared plus 4x, is correct. And the maximum here is 2, 4. In fact, we can even use this x value, x equals 2, to set up a nice boundary test. So why don't we do that? So what we have here is we have f prime of x equals 0 at x equals 2. 1, 2. We could think of this as a nice country boundary. This is Canada, USA. And let's just pick any old citizen. Let's pick a Canadian as being 1. And let's pick a US citizen as being on the right hand side, which is going to be 3. Now let's do a derivative test. The derivative is f prime of x equals negative 2x plus 4. And we're going to substitute the slope is equals to negative 2x plus 4. So the slope is equals to negative 2 something plus 4, and the x value happens to be 1. So the slope here is going to be 4 minus 2 is 2. So in Canada, we're going to say that the slope is uphill, increasing from left to right. The graph is increasing, and we know it is increasing because it's a parabola. We're going up, positive slope from left to right. Now what about in USA? We're going to say f prime of x, which happens to be 3. We're going to test out specifically at x equals 3. What's the slope? It's going to be negative 2x plus 4, or negative 2 times 3 plus 4, because we're substituting 3 into here. This is going to be negative 6 plus 4 is going to be negative 2. So it's going to be decreasing. Negative 2 is a negative number, which means the slope is negative. The slope or rate of change is negative, decreasing. So when a function is increasing then decreasing, we call this a maximum. And when a function is decreasing left to right and then increasing, we call this a minimum. Now be careful, you can't assume just because the derivative is 0 that the function has a maximum or minimum. The function could be increasing and increasing again, such as the cubic function. If you say y equals x cubed, it's going to look like this, like an s, and the derivative is 0, but you have to be careful.